Hello, everyone. So happy to see that all of you decide to come to the lessons. Anyway, we're moving forward very slowly. Look at this new lesson. It's called integration by parts. It says that the integration by parts is a method based on the product rule of differentiation. And in the table, you can see the formula. One moment. Now, if you read the formula, it says that, anyway, it's weird that you don't even see dx. Here you see two variables, that's v and u. And it says that, oh, this equal this minus this. Now, before we go into the proof part of this formula, I want to first introduce how to use it. Now, usually when you see two kinds of functions put together in an integral, that is when you think about, oh, maybe I need to use the integration by parts. Because integration by parts, from the name, you can guess, oh, I need to integrate part of it and then the other part. So in this first example 25a, now in this integral, you can see x, that is a polynomial, usually I call that a polynomial, and cosine x is a trigonometric function. Now that is a clear sign that it's a mixture of two basic functions. And then to integrate directly, I don't think there's a way. Okay, so this is what we do. Instead of integrate everything, what you do is you integrate a part, which is cosine x dx, and that is changed to, it's like in integration by substitution, but here, although I'm doing substitution, but I'm not writing it, it's d sine x. That this step is called integration by part because part of the function is being integrated. Part of the function. Like cosine x dx now is replaced by d sine x. Okay, so that is the by part. This is the by part. And then what we do is, look at the formula. It says that u dv. Now here u is x. U dv. U is x. dv is d sine x. So u is x, v is sine x. According to the formula, it's equal to, u times v. U times v. Here is u times v minus integration v du. So I'm swapping these two functions. That is v du. Now try to follow. You see, u, right? And that's x. V, that's sine x. So uv, that's x sine x, minus v du. So you swap these two. Now x becomes the dx instead of d sine x, dx, and sine x is outside. You swap these. And then it's sine x. Because this time the integral is not a mixture anymore, then you can integrate immediately. Okay, and then you simplify. that okay? Another example, this one. You see, in the example, there are two types of functions. One is polynomial, the other one is exponential, also two types, two different. And what we do is to integrate one of them. In this case, I'm going to integrate e to the power x dx and change it to dex. Now here is the integration by part, and also it's the same as the integration by substitution. It's actually the same as integration by substitution. In this case, it's integration by parts. That's one part integrated. Okay, now you need to identify which one is u and which one is v. Now here u is the one outside, so this one is u, and this one is v. Okay, one is u, one is v. Now this integral is equal to u times v minus integration v du. You swap them, and then you will get x ex, because this is not a mixture anymore. Now after you do this, it's not a mixture anymore, you just integrate. This is e to the power x itself, and then you're done. Is it easy to use? I don't think so. I don't think so. It's the hardest part, I think. Even worse than integration by substitution, because you have to do substitution first, and then you do the integration. I'll show you more examples. Is that okay? Now write it down first. Write it down first. I don't want to go too fast. But if you have no question, I'll move on. Another example. It's the same question, it's just that these are more complicated. Okay. So with this one, you see still a mixture. Do you see mixture? A mixture. And when you see a mixture, most of the time you need to do that. That is equal to negative x first, sine 2x d2x first. Now this cannot be done in one step because the angle is 2x, so I need to multiply 2 first. You see, I moved the 2 inside. I moved the 2 inside. Can I add a highlighter? And then add a highlighter. Here 2 is moved inside. Okay. And then x, we cosine 2. Okay. Now here, this is the integration by substitution, but also here it's called integration by parts. I put the negative and d sine x. And here, this is my substitution. That's negative sine 2x d2x is replaced by d cosine 2x. So you can see the negative sign is gone. Okay. So in this question, I need to adjust the angle first and then do that. Anyway, Now I'm ready to use the integration by parts formula. Identify which one is u, which one is v. In this case, this is u, this is v. So it's equal to u times v minus v du. Do you see these two switching places? And after switching places, you can see the mixture of the function is gone. It's gone, leaving you only trigonometric function. And then it's done. And then it's done. Okay. For this one, the first I will rewrite. Now this is, I'm not ready yet. I'll rewrite. Rewrite. Okay. And then I'm going to integrate this part. Integrate this part. The exponential first. Exponential first. The previous example, I do the trigonometric first. This one, I do exponential first. Now this time, it's actually either way, whether or not you put the negative inside or negative in front. Now my habit is that I put the negative inside. I guess if you're learning from me, then you learn this first. I always want to put the negative inside. It's just less troublesome to me. Okay, so here I put the negative sign inside. There's a negative sign. Let me know if you don't know why there's a negative sign, because that could be a problem. There's a negative sign. Okay. And then I'm ready to do the UDV thing, UV. This is U, this is V. Okay. And then I'm doing U, V minus V, D, U. Now UV minus UV, D, U. Is that okay? I hope so. I hope so. Now, I will use another step to sort out the signs. So here in this step, I'll sort out the signs. This is negative 2x minus 3 e to the power negative x plus e to the power negative x d 2x minus 3. Now, I know the sign is always a problem, so I will deal with the sign. I will make sure the sign is correct in my next step, and then I move on. Now, this part, I need to simplify d to x minus 3. So this is what I do. Instead of, this is what I do. I put 2 in front. Now there, when I simplify there, it's another substitution. It's so really the substitution is everywhere. You see, this is substituted by this. Is another substitution. And then finally, I think I'm ready. Like that, right? And then in my final answer, I want this to look good. So I will take out negative e to the power negative x, and I will do 2x minus 3 plus 2. And then my final answer is negative this 2x minus 1, close bracket, plus c. Is that okay? But in today's lesson, I will use more than normal amount of examples to show you how this is done. So with the 4 examples, you must finish the classwork. You must finish the classwork and let me know when you're done. I will write down the answer in detail as well. Okay. Now, not everyone finished. But I admit that this is the weirdest thing you're gonna learn. It must be. It must be. This kind of calculation, I guess it also falls under the umbrella term algebra. This is the weirdest thing. The weirdest thing. When I first learned it, it's also very difficult to. It's very difficult to master this. Because it's just not normal. Everything you do is not normal. Now, again, this is the answer. I'll explain in detail. For part A, you will do the trigonometric by part. By part. Sine is d negative cosine. Again, I usually put the negative sign inside. Okay. And then it's uv minus v du. So identify which one is u, which one is v. So uv minus v du. That's integration by part. And then I will sort out the signs first because there's not a lot of negative signs. I'll sort out the signs first and then I'll integrate. This is the final answer. May I please remind you that you need to sort out the signs first before you move on. Please always sort out the signs before you move on. Part B. Part B. Now, this integration by parts involves the coefficient to be adjusted. This one, e to the power 2x, is 1 over 2. No, d1 over 2 e to the power 2x.
Sorry, Ms. Chen, I have a question regarding the first part. Do we have to add 2 in front of x in order to integrate e to the power of 2x?
Part A.
Do you mind if I draw it on the screen?
Part A.
Part B.
Part B. Say again.
Can I write d2x? Do we need to write d2x in order to integrate the e to the power of 2x?
You mean add another step? You mean add another step?
No, I mean added 2 here.
Oh, do you mean this? Now, can I write it? Is it x plus 1 e to the power 2x and then 1 over 2 d2x first? Do you mean that?
Yes. Mm-hmm.
Depending on your needs, Sophie, depending on your needs.
Okay, thank you, Mr. Then would it be
after a few weeks now? I don't think you need it. Yes.
Would it be 1 over 4 in this case? Like this should be 1 over 4.
1 over 4? Why 1 over 4?
Wait, sorry, Mr. Maybe I have to think for a bit. Sorry.
I don't think it's 1 over 4, huh? Because
okay,
if this is 2x, then this is u du, and this is u now. This is u. So there is no need to add another 1 over 2 in front.
Okay, thank you, Ms. Chen.
You know what I mean? If you do that, then do you know what I mean?
Yes, thank you.
I think you add 1 over 2 twice, but it only has to be done once. Now, if you need the step that Sophie just asked, that you want to adjust the 2x first, that's fine. That's fine. But in the end, you will get this. Now, maybe in your answer, you put 1 over 2 in front. That's okay too. If you put 1 over 2 in front, that's okay too. It's just later on, I think your steps may vary a little bit. You may need to add a lot of brackets because the 1 over 2 is in front of the whole integral. Is it fine? Now it's uv minus v du time. You see, if I put 1 over 2 inside, then that's uv minus v du like that. But I use one step to sort out the coefficient. You see, the 1 over 2 I put in front, and also finally the 1 over 2 I also put in front. I guess in the end I still put in front, and without bracket. Without bracket. I didn't write 1/2 times bracket something without bracket. Is that okay? And also there's another what you call a simplification, but it's actually a substitution, integration by substitution. There, well, it's very subtle, but it's there. And then you do the integral again. And then after you're done with the integral, you need to simplify this integral. And the best thing to do is to take out a common factor, not to expand. Please don't expand. You need to take out 1/4 instead of 1/2. You take out 1/4. I know you're not used to this, but think about what will happen if you take out 1/4. Now, this is what's left inside the first bracket. Now 2x plus 2 instead of x plus 1. It's 2x plus 2 and then minus 1. So find the answer 1/4 e to the power 2x bracket 2x plus 1 close bracket plus c. I know it's the first task, but it's not easy. Okay. Now, I think now we're a little bit ready, not entirely, but a little bit ready to look at the formula itself. And you need to see where it comes from. Now, this formula comes from the differentiation. This is the product rule. Do you see? It's the product rule. For product rule, if you integrate on both sides, that's what you do. You integrate on both sides. You see, integrate on both sides. Okay. Now on the left, this one, I need to circle this. This one equal this one. I think you need to understand why this one equals this one, because it's a differentiate and then integrate. That will give the original function itself. Look closely up. UV differentiation and then integration. That's UV itself. Let me repeat. UV differentiate and integrate. You should get UV itself, because integration and differentiation, they are the reverse operation of each other, reverse operation. So that will return, you will return to UV. So on the left, it's UV plus C and UV plus C. On the right hand side, I'm splitting. On the right hand side is splitting. That is the additional rule of differentiation, not splitting. Wait. One moment. One moment. Okay, we're back. We're back. So this is to split. This is addition as two different integrals. Okay. Now the last one, the last line before the end, the last line is an integration by substitution. I'll highlight this part for you so that you see. This is u prime dx is du. U prime dx is du, integration by substitution. Also, v prime dx is dv. Integration by substitution. By substitution. And then if you move the terms around, you will get integration by parts. Is that okay? Just rationally, you need to understand where it's from. It's not nonsense. This is not made up. It's actually correct. But when you use it, you don't feel like, oh, I'm doing the product rule in reverse. You don't feel that, but it's coming from that. Anyway, does that affect how you solve the problem? I don't know. I don't know. I find that the proofs of the theorems, the proofs of the properties always calm me down. Because otherwise I cannot stop thinking them. Always calm me down. You just go with whatever feeling you have now. But that is the proof. That is the proof. Now let's solve more. Let's solve more. I have the responsibility to show you a lot of examples, so you are finally maybe a little bit comfortable before you do homework. Example 26. Example 26, you don't see the integral, that you don't see a mixture of two types of functions. You don't see that. You just see one single function. That's log. Now usually we say, oh, it's a one single function. Should I use integration by parts? For this one, it's a special case. For this one you need to, although it's not a mixture, but with the single function, you must also use the integration by parts. Otherwise, it's not possible. It's not possible to solve it. Now this one is also very unique because I don't actually do the integration by parts. The step, I already know which one is u, which one is v. Now I'll point it out to you. Now this one is u, this one is v. It's already there. Now log x is u, x is v. Now this is v is too simple. V is too simple. So it's equal to u times v minus v du. You still see me switching these two functions? Okay. And then there is this integration by substitution happening here. D log is changed to 1 over x dx. Now, I think every time we do something new, you will wonder, oh, can I do this? Yes, you can. Yes, you can. D log is 1 over x dx. And then that's a substitution. And then you will get log x times x minus 1 dx. And then you will get log x times x minus x plus c. And then you're done. This very simple functions integration has to be done by this formula. Is that fine? For another example, this one is a mixture, obviously. It's a mixture. It's log and what do I call it? It's not a polynomial anymore. It's a fraction. It's a rational function. So log and rational function. For this one, I will integrate the rational first. For this one, it's d x negative 1 over negative 1. Sorry, I shouldn't. Do you see that? This is also something that you need to practice. Now with the negative 2 power, I will change it to the negative 1 power by integration. It looks like if I'm putting something inside the D, like inside, like behind D, then I'm doing integration. Do you know what I mean? I'm integration. And then if I'm taking out this out, it's differentiation. It really is like this reverse way you're doing back and forth, back and forth. It's both the integration skill and the differentiation skill. Okay. Now I'm ready to do the integration by parts because that's u v. This one I'll just write negative x negative 1 minus v du. uv minus v du. And then one step to clear out all the signs. This one is 1 over x d log x. The one step to clear out the signs. Okay. And then what is it? Another, this is similar to part A. I have another integration by substitution. Dx changed to 1 over x dx. And then it's negative log x plus x negative 2 dx. And this time when integrate, you can get the there you go. Is that okay? Are you following? These two examples show you what happens if you have log inside. Now, when you have log inside, you should either do that. A is very, very peculiar, I think. That's very unique. Part A is very unique. But for part B, you should integrate the part, which is the rational. The rational. I'll show you another one. Sorry, I need to wait. Let me wait for one moment before I move on. If you have any question, you ask me. Okay, no question, then I move on. Example B. This one is also a log itself, a single log. Although inside is a little bit more complicated, but still. Look here. This is our u, this is our v. In this solution, I will do log directly, just like the previous one, although it's much more complicated, but still I'm ready for that. So this is log now may I just make sure that you know that log is ln, not in. Some of you are still writing in. I don't understand. I write l. It's log, lon, log, l. For this one, look what I do. This is the substitution here. There's a substitution here. I have to simplify d log this. So that is 1 over the reciprocal times this. Please follow. That this is log something. Now log something. So if you want to differentiate, that is 1 over something, and then you need to differentiate and then dx. Tell me if you don't follow. If you don't follow this part. Imagine this is log y. This is log y. If I want to d log y, that's 1 over y dy dx. Dx. 1 over y. This is the reciprocal. And this is the chain rule in that. Tell me if you don't follow. This is the substitution. Substitution. And then for this differentiation, that is d high low minus d low high divided by low square. I have no easier way. No easier way. I'm sorry. Now this one, if you delete, you will have actually -1 divided by x plus 1 dx. In this case, that is plus, right? 1 over x plus 1 d, and here I'm adding x plus 1, another substitution. And then in the end, I have this. Is that okay? Now, girls, let me remind you that the absolute value sign is not optional because in the question, I do not have the confirmation that x plus 1 is positive. I don't know. Unless it says somewhere. Unless it says somewhere in the question, hidden somewhere, and then you can remove it. Otherwise, you must keep it. Any question? If no, let's move on to the second question. Second. This one is a combination. It's a mixture of log and this one. Rational. Oh, not even rational. Irrational. 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 Anyway, this one I will do 2x 1 over 2. That obviously this is faster than usual, but spend some time think about this. This is like a lesson 2 weeks ago that you have to learn. That 2 weeks ago when I explained this, you have to learn that step by step. This is one step. One step you get that. Now you can see the power from -1 over 2. It's raised to 1 over 2. How did that happen, right? How did that happen? And the coefficient wasn't there, and now there is a 2. Why is that? Why is that there? Why is that there? Okay, now we're ready. It's u v minus v du. Okay. And then one step, I will figure out the coefficient first. This is 2 x negative 1 over 2, 1 over x dx. And then 2 log x, x 1 over 2, minus 2 x negative 3 over 2 dx. And that is 2 log x, x 1 over 2, minus 2. This one, it's 1 over negative 3 over 2 plus 1, close bracket, x negative 1 over 2. I hope that's clear. I hope that's clear. Okay. So that is 2 log x times x 1 over 2 minus, I think plus. Make sure you're correct with the coefficient. It's 2 times 1 over negative 1 over 2. That's plus 4. Why is it? Plus 4 x negative 1 over 2 plus 2. And then you're done. Unless you want to do some simplification. In this case, I don't see the point yet. So you can leave it like that. A moment. A moment to take in. To take it in. And I also hope that you can see some resemblance of example 26a and 26b. It's just B is a more complicated version of A. Now you will do the exercise and you let me know when you're done. I will show you the detailed answer later. One moment. Girls, one moment. Come back. Sophia, can you speak out? Where?
When you apply the integration by part, why is it negative 1 over 2?
Oh, I copied it wrong. Change everything. Look here. Look here. There is something wrong. Instead of negative, it's positive. I don't know why I wrote over negative. Positive. Oh my. Positive. Oh no. There. What? Oh my. Oh my God. Oh. Positive. Negative. And then positive. Please change that, everyone. change that. Thank you. I wrote it wrong. I don't know why. I don't know why. Change that. Change that before you move on. Yes, it's positive 1/2. Yes. Okay. Let me show you the answer. Now, because I want to be more consistent with the method I just taught, some of you may have a different solution, but that's completely fine. Now you should check with me if you have a different solution. For this one, now if I use the same solution as I showed in the example, I will just use the integration by part formula directly. And then with this, to simplify, I have to do a lot because it's not a simple function that I can replace it. It's a what do we call it? Composite function. That is 1 over u du, you see? That is 1 over u prime. And you need to simplify a lot. And then the answer, In this question, you don't have an absolute sign. You don't. You don't have to have it. There's no need. Moving on. The second part. Now this one, the substitution is here. -3 is raised to be -2. When you're doing integration, the power is always raised. The differentiation, the power is always brought down. This one is raised. It's raised, and the coefficient also appears from nowhere magically. And then the integration by part, the uv minus v du. Now, after I use the integration by part, you can see the signs are everywhere. So I will arrange the signs. I will, and you should as well. I rearrange the sign, rearrange the place I put the coefficients. The best way to write it, basically, the best way to write it. And then there's another substitution. Now this one is much simpler than the previous one. That's d log 3 over x. This one is d log x. It's way simpler. And then the substitute, then the answer. The final answer is here. This is the final answer. This is not rearranged or anything. I just leave it there. But of course, I think you can take out a common factor if you want. Any questions? Now, these two examples are the basic ones. But this formula, like I said, in order to use it, you have to do the substitution. You have to, because the first step is to integration by parts, and by parts means to replace something. And that is substitution. So to do this well, you have to know the substitution well. Shall we move on? It's 1 hour already. Move on, move on. Now, before we enter the next stage, there's the little practice I want to do with you. This wasn't included in my previous teaching material, so this is new. Now, this practice is that when you have a mixture of functions, which one do you do first? So to complete each of the following and then decide which one, the first or the second, is an appropriate step to find the integral. Now for the first one, it's a mixture of x and cosine, x and cosine. I can integrate x first. That is x dx is changed to dx squared over 2. Now I'll leave the cosine outside, and then I will replace x dx with dx squared over 2. Now you must imagine whether or not this one will work out. Later on, I will ask you, okay? For the second choice, obviously I will leave x outside, And I will replace cosine 4x dx with 1/4 sine 4x. This cosine 4x dx change to d 1/4 sine 4x. Now, which one is an appropriate step to find the integral? 1 or 2? Iris, what do you think? 1 or 2?
2.
2. You're correct. 2. Second question, a mixture of x and log. Now I can integrate x first. Or I can do nothing in this case. Nothing. Do nothing. That means to use the integration directly. That means to use the integration by part directly. This is weird. I integrate x, integration x dx first, or nothing. Which one? The first one. The first one. Last one. It's a mixture of x squared and e to the power 5x. The first choice is to put x squared inside. That's x cubed over 3. The second choice is to put e to the power 5x inside, which gives you e to the power 5x divided by 5. Which one should I use for this to work out? 1 or 2? Sophie.
Sorry, Miss Chen, I don't really know.
You don't really know. It's fine. It's fine. Because in 27, example 27, we're going to review this. You see 27a is very similar to this question. I will show you which one will work out. Don't have to choose yet. So for this one, I copy the question, x squared e to the power 2x dx, that is equal x squared d 1/2 e to the power 2x. As you can see, I already picked the second one. I already picked the second one. And then I will do u v d u. Integration by part. Okay. And then simplify. This one is 1/2. This is 1/2 e to the power 2x. This one is 2x dx. Now this one I need to point out because may not be seen very clearly. There is a simplification there, a substitution. And then to further simplify, there is x e to x dx. Okay, so it's a little bit simplified. And then the second time, integration by part twice, the second time. second time. Do it again. And then and usually I put bracket, and then the next step I will remove the bracket. This one. And then the final answer. And of course, the answer looks much better if you take out 1/4 e to the power 2x. That gives you 2x squared minus 2x plus 1. Let's see. It looks better if the exponential function and the polynomial are separate. So right now, I think you know that which one will work out. Which one will work out. With the exponential and the polynomial, you should do the exponential first. And then you have to do it twice. Look closely. The first time you've done it, you have reduced this to a degree 1. Oh, sorry, this one. You will see the difference. I don't think that the e to the power 2x can ever be eliminated. But the polynomial part, you can see it's down. Now, do you see the 3 underlined parts? The integral. Each time, this one is a quadratic times exponential. This one is a linear times exponential, and this one is just linear, just an exponential. So every time I think the difficulty level is reduced significantly. Is that okay? In our curriculum, yes, sometimes you will have to do this twice in order to find the integral. Okay, that's one kind of difficult. Part B. Now, part B is another kind of difficult because part B, the inside the exponential is a square. So this is what we do. I will split x cubed into x squared and x and write it this way. Okay. And then I'll begin. Now, this is me revealing to you what my true intention is. So I should put the bracket here, not here. I should put the bracket here. Do you know what I mean? Now, in this case, I suggest that it's a better way if you just change x squared to u. Now, it's a better way if you let u be x squared, because writing is smaller. Writing u, e, u, d 1/2u. That's easier to write this way. It's less writing. Is that okay? And then this is 1/2 u d e u. Integration by part. Maybe I shouldn't be this fast. Just slower. Slower. And then 1/2 u d e u, and then 1/2 bracket u e u minus e u d u close bracket, and then it's 1/2 u e u minus e u close bracket plus c, and then I'll change it back and take out e to the power u. E to the power u minus 1, and then done. So in part B, there's another kind of difficulty is that it's a composite function. Sometimes you may need the assistance of another variable in order to figure out quicker. Let me know. Write it down. Write it down. Wait for about 1 minute. No question. Okay, then we do another one. It's the same, but with different functions. Same type, but different functions. This one. This one. X squared d sine x. Okay, so this is the first time you use it. That's the first time. Okay, now the second time. I'll put 2 first. I'll put 2 first. That is x d negative cosine. You see, I leave x outside, I put 2 outside, and then I integrate sine. Integrate sine is cosine. Okay. Now this time, before I use the formula, I will adjust the sign first. I will, well, because later on there'll be too many. Adjust the sign first, and then use the formula. And then in my final answer, I will remove the bracket. Is that okay? It really has twice integration by parts, twice. Now for the second one. Part B, You see, it's still a composite. This time, now 5, I'll leave it with 3. And then x squared dx. I'll split 5 into 3 and 2. 3 and 2. And then you know what my intention is. This is x cubed sine x cubed. This one is d1 over 3 x cubed. Like that. And then of course I want to use another variable so the writing is less. You don't have to u equal x cubed. U sine u d 1 over 3 u, and that is 1 over 3 u sine u du, that is 1 over 3 u d negative cosine u, and that is 1 over 3 bracket u times negative cosine u minus negative cosine u du. In this case, it's 1 over 3 negative u cosine u plus cosine u du, and that is 1 over 3 negative u cosine u plus sine u, close bracket plus c. And then my final step is put u back, put x back, remove u, negative x cubed cosine x cubed plus sine x cubed, close bracket plus c. Is it fine? Now for the second time, instead of a mixture of polynomial and exponential, I have a mixture of cosine and sine. Cosine and exponential, not cosine, trigonometry and polynomial. I hope you can see how similar they are. Is it fine? Now 1 minute to write it down. And you should also notice how careful I was with the signs and how careful I was with the coefficients. The only way to make your answer correct more often is to write everything down, I think. Now, if no problem, I'm going to show the third one. This one. Still. First question is a mixture of log and a polynomial. No, log and x. Log and x. This is log x over x squared dx. That is equal to log square x negative 2 dx. Right? And that is log square. If I put square here, I don't have to write a bracket. And then this is d negative x negative 1. Okay, so that's the first time. The first time, that's the first time. Now to make this look better, this one is 2 log x times 1 over x dx. I don't know if you see it. Now this is a composite function. So to simplify it, I have to use chain rule. I think chain rule must be the one that you hate the most when doing differentiation. But here is, you can't run away from it. Still you can't run away. So this is equal to negative log square x times 1 over x times and plus, I'll put 2 inside in front, and then log x, and then this is negative 2 again. This is negative again, so this is d negative x negative 1 again. I don't know what happened to my pen. That's what it is, and then that's the second time. Second time. Now, second time, there's a lot of negative. I need to deal with the negative first. This one is 1 over x. This one is 1 over x dx. Okay. There. So this one is a lot of negative. And then for this one, I think I'm ready to take out negative 1 over x. Negative 1 over x. And then you have log x squared plus 2 log x plus 2. I think that looks better. Definitely looks better this way. Is it fine? So this is an example when you have a mixture of log and x, and then you use the integration by part twice. Last example. The last example is not because it's more difficult or anything. It's not like you have to use the integration by parts twice. It's that the base 7 is not the best. Base 7 is not the best. And we can't deal with base 7, basically. That's not good. That's not good. So what we do here, so for this question, I don't think it has anything to do with the previous example. It's just for this question, if you see a different base, this is what you do. One with a different base, you must change it to the same base. You change 7 to e to the power log 7. That is how you change it. E to the power x times log 7 dx, and then that, and then you just use the integration by part once. Okay. And then you get this answer. Okay. And then that's not the worst part. The worst part is to change it back to base 7. Change it back to base 7. And then you change it back to base 7. Is that okay? I'm not sure whether or not, because in the public exam this did appear once with a different base. So I guess you have to know how to do the different base one. The identity you use is that any number, let's say 5, any number equal e to the power log 5. Now 7 equal e to the power log 7. 10 equal e to the power log 10. That's how you use that. That's how you change base. Now I have no doubt that this may be more difficult than these ones. You have to apply to integration by parts twice. I don't know. I don't know which one is more difficult. Even more difficult than this when you have to do a substitution. I don't know. I don't know. Anyway, I'm putting it out there so you can learn and practice. There's a practice right away. You can do that and let me know. If you need a hint for part B, let me know. If you need a hint for part B. Now, if you're stuck, in part B, you should let u be square root x right at the beginning. Try let u be the square root of x. There is my hint. It's on the screen now, on the screen. Okay, more done, more done. This is my answer. The first question you have to do twice, and this one is more difficult because there is a negative sign. It's a negative sign here. And then I will have the extra step to arrange the signs. I really will. I will rearrange the signs. And then do it twice. This is to do it twice. And then my final answer is this one. I separated the exponential function with the separate from the polynomial. The part B is very tricky because it's not easy to see. Now, although I used two examples that was very, very clear that what you should do and what u should be. This is u equal x squared. This one u equal x squared. This one u equal x cubed. But this one is not so easy to see. I guess it's kind of easy, but you have to do it right away. Right away. Let u be square root x and x be u squared. Now these are just inverse of each other. This one is 1 and this one is the inverse, the other one. Now they are the same. They're the same. And then put it back. Then I will have e to the power u du squared. And this one is a substitution here. No, this is the substitution. Later on, you will change du squared to 2u du. And then you take it out, and then this is, and later I think with the integration by parts, it's not that difficult. But the change of, the integration by substitution part is more difficult in this case. The final answer is 2e to the power root x times bracket root x minus 1, close bracket. Do you have any question? No, that's good. That's good. Now for the final example, I also prepared 1, 2, 3 examples. But I'll just do one this time. I'll just do one this time. For this one, it's a mixture of exponential and trigonometry. This is the first time we always have this and that, never these two. With these two combined together, this is how you solve it. E to the power x sine x dx. I'll leave sine outside. I'll leave sine outside because e to the power is easier for me. So that is sine x ex minus ex d sine x, and then sine x ex minus, this one is ex cosine x dx. That's the first time, completed. Second time, sine x ex minus, again, I put e to the power x inside. I like it because it's simpler. Okay, the second time. And then I will have sine x ex minus cosine x ex minus ex d cosine x. And then it's sine x ex minus cosine x ex plus ex. This one is negative sine x dx. Okay, and then I will Again, I will deal with the signs. Okay, so after 2 times, twice integration by parts, it seems that I cannot solve it. I cannot solve it. I get from here to here, and then back here. It doesn't seem like I can do it. I can do it. If I continue, I will repeat. I get exactly the same. And this is when I stop. This is when I stop. Instead of continue, this is very unique that I will compare the both sides and get 2. What do I write? I write by comparing the terms. By comparing the terms, I will have twice the integral equal sine x ex minus cosine x ex twice integral. So one integral ex sine x dx equal 1/2 e to the power x sine x minus cosine x. Let's see. Do you see what I mean? This is very special. Now, usually you would expect that after once or twice integration by parts, this integral can be found, but in this case, it cannot be found. I get an expression of this integral. This integral is equal to an expression of the integral, and then I can solve it like an equation. This can be done. This is allowed. Is that okay? So with the mixture of exponential and trigonometry, this could happen. This could happen. That's all. That's all for today. We'll continue next time. Hopefully we can finish. If you have any question, you must stay. Otherwise, you should leave. Bye bye. Hello.